Again, hello everybody. So we want to start this part after we have finished the first half of our lecture with some exercises. First of all, GDP growth. We have the numbers for nominal growth in 2018 and 19. Also, we know the price development and the absolute value in 2019 of nominal GDP. So we should calculate real GDP growth and nominal GDP in 2017. Okay, so now let you see adding thing. I do it like this. So we start 2017. Up. And 19, we have GDP nominal. Then we need, let's GDP growth rate we need. And what else do we need? Well, let's also take the index value. Genome index, and all this we also need for the real growth rate. And what do we need? We need GDP deflator and GDP deflator growth rate. So this you can see everything. Let's move it just one up. And now we can put in the numbers which we already have. This is 3.44. Oops, maybe you can help me that I do not have to switch. What else do we have? Can I also insert? So just give me the numbers. I think here in the growth rates we have, or nominal GDP, 3.1 and 2.7. So 3.1% and 2.7%. And what else do we have? I think price development 1.5 and 2.2. 1.5% and 2.2%. Okay. Then what we also can do is taking just one base year. I explained to you that since we changed to change indices in 2005, it doesn't matter which year we take as a base year, this doesn't change the growth rates. So then we take in 2017, for example, the index equal to 100 and GDP deflator is nominal GDP over real GDP times 100. So Now we shall calculate real GDP growth. Well, actually, the first guess would maybe that you just take 3.1 minus 1.5%, and then you end up with real GDP growth rate. Well, approximately this is okay, since in this example our growth rates are lower than 10%, but actually, of course, this is not the exact way how we have to calculate it. So what do we have to do is then let's calculate the index of nominal GDP. How is it developing? Any idea? Oh, I have to open the chat or open your microphones, because in this lecture hall I can only hardly see the chat. Anybody an idea? Maybe you just type the number, because I think the first number of the development of index of nominal GDP you can just calculate in your head. If 2017 is 100 and we have a growth rate of 3.1%, then in the next year, what is the index of nominal GDP? One 3.1, or? So if 100 is growing by 3.1%, then we obtain 103.1. Because this is 100 times 1 plus the growth rate, and then we are at 103.1. How do we get the next number? What do we have to calculate? Yep. Exactly, definitely. So, and since we are here in our software package, I have already the formula, and I can just copy the formula down one cell, and we are here. And if you're clicking in here, then you see that the two cells which you are combining are also highlighted. So we just here calculated 103.1 times 1 plus 2.7%. So, and the same we can do with the GDP deflator. There we also have the growth rates. So what do we have to do here for the GDP deflator? Maybe someone from the internet? I think you can just type in what we have to do. You can hear me? Hello? Is it working here? Test, test, test. I think so. Okay, then what do I have to do? Oops. If we start with 100 and we are growing with 1.5%, take a revenue of your enterprise, 100 million, and the growth of the revenue is 1.5%. What is the revenue of the next year? So this is a hybrid lecture. I want also a feedback from outside. This works too here, huh? Then definitely it is the same calculation, but I want to know, what do I have to do now? So 100 times 1 plus 1.5% equals 101.5. Can we see this here? Well, almost, maybe. Now it's better. Okay, and the nice little thing here is, if you, so to speak, have programmed it, that I can just copy this and putting this here. So, and now we use the definition of the GDP deflator. GDP deflator was nominal GDP over real GDP times 100. And then, of course, we have also index real GDP index equals sorry, then I was too fast. So real, real GDP is then GDP deflator nominal GDP index over GDP deflator times 100. Okay? And with this formula, we go inside here. So this is then the other way around. Nominal GDP over GDP deflator times 100. This we have also to do for 2019. And how do we obtain now real growth rate of GDP? Now I want to have the growth rate. Yes, definitely. And how did you calculate this? Yeah. Mm-hmm. Mm-hmm. 1 point. Yes. And yes, definitely. So in general, we have to know how to calculate a growth rate, and growth rate in general, let's take x of t. X is our number, x are prices, our GDP, our unemployment, revenue, profits, whatever you want. And so the growth rate of x is x of t minus x of t minus 1 over x of t minus 1. So in our case here, for 2018, we have to calculate 101.58 minus 100 divided by 100. And this we can then move downwards. And if we click in here, then you see, of course, not dividing by 100, but of course dividing by 101.58. So the difference then 102.07 minus 101.58 divided by 101.58. So, and what you see here is also, this is the exact calculation. And if we just subtract 3.1 minus 1.5, we would end at 1.6%. So there you see that just taking the difference to obtain the real growth rate, then you make a slight error there, because this is only approximately true. And here also 2.7 minus 2.2 is 0.5, and the exact value is 0.49. Okay, and the last question was here, what is nominal GDP in 2017? Anybody? Does anybody has an idea? So this is just the other way around. Let's take an enterprise with a profit of 3,440,000 euros in 2019. And then we know that the profits of this enterprise has grown 2.7 and 3.1% the last 2 years. Then you calculate backward. So what you are doing is, here's my pen here. We have X. This is the number we are looking for, GDP in 2017. And this number, we don't know, has grown in 2018 with 3.1%. Okay? This is a new number. This is then GDP in 2018. This we also don't know. But we know that this unknown number has grown from 2018 to 2019 with 2.7%. So times 1 plus 2.7%. And this number now is our GDP in 2019. So 3.44. And then, of course, we know that X is 3.44 over 1.031 times 1.027. Okay? So then let's do this. So equals 3.44 over 1 plus 2.7 times 1 plus 3.1. And now you have to know, if you type it in like this, then your program doesn't know, should I first divide and then multiply, or shall I do it the other way around? Or Excel is programmed like this, that you go just in a row. So right now, Excel would now, if I press enter here, then he multiplies, the program just multiplies our number with 1 plus 3.1%, and therefore we have to insert here also these brackets that we really obtain the number that we twice divide by the growth factor. No, it's not working. Then, so, and copy. No, and paste. So, this one is then 3.5. Or, for example, let's also give you here the explicit number. So this is 103.1 times 1 plus 3.1%. Or let's take this number here. This is 105.88 over 103.733. Oops. 733. So, for example, or let's take also this number here. This is 100 times 1 plus 1.5%. Okay, next one. This is a 4. What do we have here? Oh, this is inflation. My snipping tool. Yeah. So we have a two-product economy with products A and B, and the price index of these goods have, with the given weights, the following price development during the last 3 years. The first one is jumping from 412 to 4 back with a weight of 25%. The second good stays at the same price of 8 euros the first 2 years and then is jumping to 12. And you should calculate the inflation rate of T1 and T equals 2. And then we should suppose that in T equals 3, we have an inflation rate of the average of the former 2 years. Okay, let's move also in here. So this was A3 and then take here A4. So we have GA, we have the weight GA, GB and GB, and we have 0, 1, 2, and 3 we need. We have 0.25, 1 minus 0.25, and then we have here 4, 12, 4, and 8, 8, 12. So then at first take the number to the basket, index, and inflation. So what will be the value of the basket in T equals 0? So what do we have to do? Price of good A is 4. The weight in the basket is 25%. Price of good B is 8 and the weight is 75%. Anybody? So these exercises are for you. I also can give you just the solution. But this is not the idea of exercises. So, anybody out there in the internet? So the value of the basket is defined as prices times weight plus price times weight. Okay? So this is 4 times 25% is 1 plus 8 times 75% is then 7. And this one we do for all 3 years. Again, let's choose just an index, 100, for this first year. What is then our index in the following year? If 7 equals 100, then 9 equals what do I have then to calculate? Actually, this is, I think, school math. This seems really right. And how did you do this? Yes, definitely. Yeah, definitely right. Okay, so I take 9 over 7 times 100. And then we are at your totally right number of 128.57. And we do the same for the following year. So 10 over 9 times 128. Oops, sorry. Not 100. I have to take the formal value here, this one. Because, no, here, this, I have to change the 100, not typing it, because then it would be fixed. And then I have the 142. Oops, this one. So, and inflation. Let me see if I can change this here. Opala. To, let me hear you. This one it is. Can anybody say something that we maybe hear you?
Yes, test, test.
Yep, thank you. It works. So, how do we get inflation? Maybe a bit not that loud. Oops. This is enough, I think. Okay. Oops. Okay, so how do we get inflation? This is the next question. Yeah, this is almost right. You didn't calculate the inflation rate, but the inflation factor. But this is a good idea because we need this in a minute. Inflation factor we also need, and oops, inflation. And this is then over 100, and this would be this. Because here you see, of course, we do not have an inflation rate of 1.28. So what do we have to do to obtain from the inflation factor the inflation rate? So we are almost done for the inflation. In order to be here, inflation rate. Well, divided by 100, then it's one. If we divide this number by 100, it would be 0.012. So not dividing by 100, but then we are at 128. So if you look just at the numbers, you're coming from 100 to 128. What is then the growth rate? You can do this just in your head, I think. Or idea? 28, yes. And how do we get from 1.28 the 28? Okay, then we have just to subtract 1. So this is then this minus 1. And why does it work? I show it to you in a minute here. So again, inflation rate is nothing else than a growth rate. Okay? So, and for a growth rate, we had x of t minus x of t minus 1 divided by x of t minus 1. And this is, of course, the same as x of t minus 1 minus x of t minus 1 over x of t minus 1. And this is the same. So we obtain x of t minus 1 over x of t minus 1 minus 1. And this is then the growth factor. So this in percent, and this also in percent, and let's take 2 digits. Okay, and now we want to have for t equals 3 the average growth rate of, or the average inflation rate of the former 2 years. What do we have to do then? So let's do it slowly. What is the thinking behind it? Well, we have a number which is developing from 100 to 128.57 to 142.86. Okay. How did we obtain these numbers? By 100, oops, 100 times 1 plus 28.57%. And to this number, we had to multiply this number by 1 plus 11.11%. Okay? And this is then 142.86. And the thinking now is which constant inflation rate in the last 2 years would also lead to the process that coming from 100 I end up at 142. So 100 times 1 plus pi is quite often used for inflation rate. Since we have an average inflation rate, let's take pi bar times 1 plus pi bar equals 142.86. And now we have to solve this for pi bar. So then, of course, we have 142.86 over 100 equals 1 plus pi bar squared. So we get 1 plus pi bar equals the root of 142.86 over 100. So, and then you also see that this is an averaging process. I rewrite the square root in another way as 142.86 over 128.57 times 128.57 over 100. You see, I just inserted a special one, so to speak, because these two numbers, of course, just cancel out. And what I see here is this is nothing else than the growth factor of the year 2018, and this is nothing else as the inflation factor of 2019. So this is inflation factors of 2018 and 2019. So what we have here is just the geometric mean of the inflation factors. I don't know if you have done this in statistics or in mathematics, but I think all of you know if I have x and y as two numbers, and the arithmetic mean is just 1/2 times x plus y, and the geometric mean is just x times y, and the 1/2 moves up into the exponent. And what is the importance, especially in economics, that you know what a geometric mean is? Because in economics, we quite often deal with growth rates. And if you want to average growth rates, then you have to use the geometric mean. So you can then calculate here the average growth rate. This would be then just the square root of this times this, and average inflation rate is then again nothing else than average inflation factor minus 1. And what you see here is, if we compare this with 0.5 times 28 plus 11, then let's also take the same format, that you have here a quite large difference. So this here, this calculation here is wrong, or it's only the approximate way to do it, and you are more or less, you can keep in mind, you are allowed to take the approximate form if growth rates are lower than 10%. Well, right now we have inflation rates larger than 10% also in our actual situation. So please keep in mind, averaging growth rates always take the geometric mean. Okay, so this is then also the average inflation rate. So when I copy that, you can read it. Okay, so then let's move this also into our okay, 10 minutes left. Maybe we can start one last exercise. And this one. A5, oh no, this is too long. This we will do on Thursday. Then A6. Another, maybe we can do this also. Okay. So this was A4. And then let's take A6. So what shall we do? 2016 nominal GDP was 3,017,3.15, 3.3. Calculate the per annum growth rates and the average annual growth rate between 2016-18. Additionally, between 2016-18, overall prices should have annually increased an average by 1.1%. calculate the average annual growth rate of real GDP. Okay, done. Now we have 16 to 18, 2016 to 18, and then I can just copy this one and put it in here. And we have nominal 3, 3.15, and 3, and average we have GDP deflator growth rate is 0.01. So again, we can take an index at 100, and this one is nominal over real. And let's format this to percent. Okay, done. Nominal GDP, so this is 3.3. Nominal GDP growth rate. How do we obtain this? Again, the difference between our 2 years divided by the number of the year we started. So this is then 3.15 minus 3 over 3. 5%, and the same here. What is the average growth rate? Again, this is then the geometric mean of the growth factors minus 1. So we obtain square root of 1 plus 1 plus 5% times 1 plus 4.76% minus 1 is 4.88. Here we see that this is almost the same. There would be then a difference in the later digits, that here, since we have growth rates, inflation rates lower than 10%, and they are quite close to each other, so this doesn't really differ from the arithmetic mean. So then this would mean here, on the average, our index has risen from 100 to 104.88 times 1 plus, sorry. And also we know our GDP deflator here, times 100 is missing. GDP deflator moved up from 100 to 101. On average has grown by 1%. So equals this times 1 plus 1% is 101. And then the definition of real GDP is nominal GDP index divided by GDP deflator times 100. So 104.88 divided by 100 times 100 is our index on average, and the average growth rate is then 103 minus 100 divided by 100. (103 minus 100 divided by 100). So let's also just put in here our numbers. For example, this one is 3.15 over 3 minus 1, and this number here is the square root of 1 plus 4.67% times 1 plus 5% minus 1, and this one is of course 100 times 1 plus 1%, and then this one is 104.88 divided by 100 times 100, and the last one here is of course then 103.84 minus 100 divided by 100. So I know the exam is in January, but please start just to do the exercises. We had quite the same things also done in lectures, and yeah, redo it, and I think then it will work out. So thank you very much for today, and please for Thursday have a look at my webpage. There I have other exercises, and on Thursday we will also do exercises together.